by and large, the bulk of your energy bill is actually not the electricity you're using. It's actually the cost of the infrastructure to get it to your house. And if you build a big global network, it's just going to still be super expensive.
Greetings, future fossils. This is Michael Garfield, welcoming you to another episode of the podcast that explores our place in time. And if you've been following my posts in the Future Fossils Facebook group, you're aware that I consider one of the more potent features of our time to be the transition from centralized power structures to new distributed modes of governance and the other systems upon which civilization relies. Yes, this episode is definitely a continuation of episode 52, where Jennifer Sedini and Michael Phillip and I waxed rhapsodic about the potentials of blockchain technology to transform our world. But because this is not technically a crypto podcast, I want to make it clear to everybody listening that this conversation with James Eggleston of Power Ledger is not some in-group buddy back scratch for Bitcoin fanatics. But as with all other episodes of this show, we look at the work that James and his colleagues are doing as a thin section of the whole story of what it means to be human alive today and how we are collectively attempting to address and solve some of the most persistent problems our species has ever faced. In this case, namely, the problem of electrifying a planetary culture, building resilient infrastructure upon which we can rely in an era of turbulence and constant black swan events. And in James's case, this means looking at how to create a distributed energy market, a better way of doing power than centralized utilities with brittle infrastructure that ironically disempower us as individuals from participating meaningfully by sharing the load, electrically speaking, the responsibility and rewards of a decentralized utility. What does it look like when we are radically responsible for our own neighborhoods? And how do we get from point A, fracking, coal-firing plants, energy monopolies, to point B, a world where clean and renewable energy is available cheaply to everybody? Now, we're about to get into that. I met up with James over a trans-Pacific Zoom call. So if you excuse the slightly substandard audio of this recording, I think you'll appreciate, as I did, how deeply and thoroughly the question of resilience has been integrated into every part of James's life. I found it totally inspiring. But first, a super quick shout out to this week's new Patreon supporters, Catherine Carr and Arthur Brock of Holochain, who will be on the show in just about a week. Thanks to both of you and the other 120-something people who are supporting with small monthly donations. Your $2 or $5 or whatever every month is what allows me to devote extensive time to the editing and publication of not just this podcast, but also lots of other media that I'm able to make free and public because of your support, such as the collection of time-lapse videos, 360 videos, and musical recordings I made from all of the graphical recording sessions I did for Santa Fe Institute's Interplanetary Festival last week. I was up there on stage with badass legendary folks like Jonathan Nolan and Martine Rothblatt and SFI President David Krakauer, who was episode 75's guest. Go back and check that out. It's a very lively and engaging conversation. And I'm very grateful to have been invited to participate in these discussions by projecting my own digital notes and drawings during the panels while I was on stage, as well as my own musical performance. And all of that is up on patreon.com/Michael Garfield for free. I hope that you enjoy it, and I hope that your friends enjoy it, if you catch my drift. Also, a big thanks to everyone who has been rating and reviewing this show on whatever platform it is where you find it. Obviously, sharing with your circles is a great way to get the show out there. But if you want to participate in the decentralized reputation engine revolution and turn on a bunch of strangers to this nonsense, then hop on Apple Podcasts or whatever and give this show a 5-star review. It's free because time isn't money. Let's get that right. And it's been super helpful. So again, thanks everyone who ever has or ever will help get this show out there. And with that, I end this tirade and present to you James Eggleston of Power Ledger on the future of electricity and how to cultivate resilience in your life.
So I'll just start by, I'm James Eggleston, and I give consent for this interview to be recorded by video.
Excellent. Well, James, welcome to Future Fossils.
Thanks, Michael. Thanks for having me.
Yeah, I'm excited because, as I said to you in our emails, I think that your project, Power Ledger, was one of the earliest crypto projects discussed on this show, which doesn't really talk too much about blockchain projects and that kind of thing, but I am very fond of situating people in, where, like, you are here in cosmic history, in the evolution of the noosphere, and so there's a certain thing about the evolution of our infrastructure and the evolution of our systems, the systems in which we're embedded, and our sort of awakening to our relationship to these great and mysterious things that is sort of characteristic of our time. And in that sense, your work in sort of making, like, the Promethean bolt here, like literally like our electrical grid, more sort of robust, seems to me to be part of that. It seems to me to be part of like an ecologizing of our technology, or a technologization of our ecosystemic identity. I don't know. Anyway, it's great to have you on the show, and I would love to just like invite you to just pull the cord and bite into this in whichever way you please.
Great. I think that's an excellent place to start. I guess here at Power Ledger, what we do is we don't create the wave, we're riding it. And we have an international board advisor by the name of Bill Ty, and one of the comments, or one of the phrases he uses quite a lot is technology waves. And I think that fits in quite well with what we're doing and kind of where we're situated. So, Power Ledger, for those that don't know, we're the distributed ledger for distributed energy markets. What we are is a blockchain company that provides a software solution to the energy market to enable network operators to use the market in a way it was never designed, to basically reimagine the market and enable people to become not only consumers of electricity but producers as well, and be rewarded regardless of how big that generator is. So, for instance, at the moment we have big generators in regional areas powering cities with lots of infrastructure in between. That model of delivering energy that way is quite a costly way when you consider new ways where we can generate energy much closer to the point of consumption. And so we're seeing this kind of transition in the decentralization of generation assets, and our software has kind of come in just at the right time on the wave to ride it, to be able to help facilitate that transition and ultimately hasten or accelerate the decarbonisation and decentralization of the electricity network. But to speak more to your point, I guess since the 50s, 60s, and 70s, we saw lots of kind of physical signals converted into ones and zeros. So we started to realize as humankind, in terms of where this comes from, we realized that if we put once we understood the photon, and we understood that if you put an electrical current through a wire, you could create a signal like a 1 or a 0. And then from the ones and the zeros, we were able to then do things with them. So we saw the birth of early microprocessors and computing chips and things like that. These types of changes or paradigm shifts or steps in technological innovation underpin what we do today. And as you can appreciate, once we get the ones and zeros into a processor and put those processors together, humankind started to create these computers, and they're probably as big as a room. Everyone's probably heard that before. It's nothing new there. But those computers were isolated, and people were performing very particular tasks on them. So from that, we then started to see the need to connect those computers together. So, for instance, within an office, you might have two of these big machines. You might be designing something in those computers. It may be the 70s, maybe even the 80s. But you want those two computers to talk to one another. So what happens then is we started to experiment with networking and intranets and things like that. And then ultimately, as an evolution naturally occurs, we started to see computers being networked all over the place, and bigger networks joining other networks. And so we saw, ultimately WANs, like wide area networks, and LANs, local area networks, grow so large that they then became interconnected and formed the global internetworked operation, which we now refer to as the internet. And so, from understanding photon movement and, electricity flow right up to networking computers over a global internetworked operation, we then started to see this amazing innovation now referred to as graphic user interface. For instance, when I was a teenager and or maybe in my primary years, and we had a dial-up modem, who could imagine that what we would use that internet for in subsequent 20 years was just unforeseeable. And one of the big innovations that really transformed the use of the internet was how we interact with it. So, for instance, if you told me when I was, a very young teenager that there would, in the future, there'd be a website that we'd all be bending backwards over to upload our personal data for free, I would have said, absolutely not. There's no way that I would ever do that. But graphic user interface is an amazing innovation, because that's exactly what did happen. And people around the world, everyone connected to the network, for instance, it just cannot help but upload their own data onto the network to share. And the mechanism to do that is you're sharing with your family and friends, but obviously you share with everybody. So graphic user interface then led to data as an asset, because before that we had large amounts of data, but once we saw the real-time uploading of photos and things like that, that really exponentially drove the increased need for storage of data, and that data was valuable. In fact, now, if you're in a factory or something, or a couple of factories, if your factory burns down, one of the factories, in days gone by, that the destruction of that hard asset, it's still suboptimal if your factory burns down. The destruction of that asset was bad, but now if you have the data, no problem, rebuild. All your manufacturing processes, you still have your customer client database. How you've been improving your product over time. It's the data now that is that very precious resource. And so through that, it's funny that a digitized, almost non-material, object is now more valuable potentially than a material object, which is really interesting, because I guess we socially construct our value around that. But from data as an asset class, then came in predictive analytics. So, now we have these big haystacks of data. How do we find the needle? How do we do something with it? It's all well and good having a big pile of data, but how do you analyze that data? And, how do you kind of get some more value out of it? And so through that innovation, not only is predictive analytics today a huge focus, particularly actuaries. So people that use actuary science to try and make future predictions. But the move to data as well, the dematerialization that I talked about before as well, when you combine big data and dematerialization, that lended itself very well to the economy and in terms of spending. So in terms of spending money, when you and I catch an Uber or something like that, no money ever physically changes hands. I I call up the service, I get in the car, I get out, I walk away, that's it. But the value is digitally transacted over. Now that's transacted using an old banking system. It's a digital one, but it's an old one. And it's a system that in some cases can take up to 3 days to settle, which is quite interesting when you consider it's just a digital signal. No one's waiting for Fred or Jeanette to arrive at the bank on 9 o'clock on Monday morning to approve the transaction and copy and paste the transaction over. It doesn't work like that. It's all machines. But why does it take 3 days? It's, in this day and age, not so good. Particularly in Australia, the country I'm calling you from, we have 98% contactless payments. So what that means is that every shop I go to, I don't even have to put my card in a machine. I just wave my bank card over it and pay it. Done. 98%. In fact, it's strange for me to go somewhere that doesn't have that feature. But I know I travel quite a lot for work, and I realize that I believe we have the highest amount of non-contact payments. The payment, although that's quicker, it's still slow. And so that's what's brought in the application of blockchain. So, in parallel, so those are the waves, there's photons to electrical signals, to ones and zeros, to computers, networks, to global networks, to data as an asset, data analytics, dematerialization, and now blockchain. And we're kind of at the very beginning of that.
So all of this is it seems like the way that the narrative cast is that of a trend line toward increasingly robust and resilient systems, right? Where you're not relying on this, the single point that's intermediating a particular transaction. You're not relying on a singular piece of infrastructure in order to provide electricity to a whole area. And so how is this, is this in your mind, I guess in this project specifically, is this more of a resilient network that's able to absorb damage, or is it, like Nassim Taleb talks about, the anti-fragile, that it's actually learning and growing from its wounds? It's like attacks on the system. I'd be curious to hear about in practice how this is playing out in the way that Power Ledger is decentralizing an electricity market.
Yeah. Look, I guess I will start by pointing out that we're a software company, and there's many kind of technological transitions occurring that are leading to this decentralization, particularly in the energy space. I guess a prime example to lead into that would be the US Navy's invention of the internet as a technology. So when they invented that, they wanted a communications network that didn't have a head that could be cut off. So if a node was struck in an attack, the whole communication network wouldn't go down. So so one of the primary, regardless of the application, one of the primary reasons for decentralization is for resiliency. And so in an electrical sense or electricity sense, or delivering utility services, for instance, when our grandfathers were growing up, the only feasible way to provide non-stop energy to a town or a city was to build a coal-fired power station on top of a coal mine. Like, that was it. And the reality is that no one wanted to live next door to that. So you had a big generator. You then had to have lots of infrastructure to transmit that energy and then to distribute it. And that was a big centralized system. And that was invented the year that the jukebox was invented. So to give you a sense of timescales, that was that, and that's how
that's great.
Still provided today. Strangely, jukebox, nowhere to be seen. Lots of coal-fired power stations out there. So now there is a move towards decentralized energy, and the reason for that is renewable technologies. Now, whether or not there are climate skeptics out there, and there are others that may believe that the green agenda is a money-making machine. Regardless of whether you believe that or not, about the damage that carbon can do on the climate, look, economically, renewable energy is just a cheaper source of energy. So, if you're comparing, if you've got $100 million and you want to get into the utility sector, regardless of your views on climate change, that $100 million will be better spent buying renewable generators than it will be buying either a gas turbine or a coal-fired power station. And
when did that shift? Because that's been a recent thing. I know Ramez Nam's been going around talking about the exponential decline in solar cost.
Yeah. So economies of scale have driven that, but I guess it's within the last 5 years or so. But the interesting thing is that obviously you're not buying fuel, right, with renewables. That's the cost saver. That's the hook. But yeah, in terms of the cost curve, there are a number of renewable technologies at the moment. Solar and wind are generally, in addition to pump hydro, which has been around for a long time, are generally the most selected options for various reasons. By and large, the fact that we're making so much of them drives down the price. Simple as that. If you look at any report about global spending on electricity, each year now, more money is spent on renewables than any other source. So money is obviously still going into putting in coal-fired power stations and nuclear and gas and things like that. And some of those technologies, for instance, like gas is a fantastic transition fuel. So, if you are operating a city and you want to transition to 100% renewables, gas turbines are certainly a great way to do that. There's a series of reports that clearly articulate why that is the case. And the beauty about a gas turbine is that you can turn it on or off in an instant and ramp it up to provide constant electricity. So whereas with the other with the other technologies, it's much more difficult to do that. But basically, with the renewable transition, we've seen the price for renewables come down. But the other important factor that's really driving uptake is actually the decreasing cost of storage, of battery storage. That's the holy grail, because as you can appreciate, most places on the world, the wind doesn't blow all the time, and obviously the sun doesn't shine all the time. So with those technologies, you're going to have to deal with the fact that you won't be generating 100% of the time. And battery technology, through economies of scale, such as with your mobile phone manufacturing globally, now every device that we carry obviously has a battery. Just those massive supply chains producing batteries has also led to the decreasing cost of batteries. And so that'll happen in the last 5 or 6 years. The cost for batteries is probably still a little high. We're probably still seeing largely only early adopters purchasing batteries. But at a household scale, for instance, where I live in Australia, I do work all over the world, but my market that I'm actually currently connected to is very, very easy to model. We have one price for electricity. It's a non-contestable market. Around the end of 2019, it'll be cheaper for us here in Perth to have a battery and solar system than it will be to be buying grid source electricity. And to tie this into your resiliency question, so basically what that means is it's actually a great thing for the network, because what we'll start to see is we'll start to see less reliance on centralized generation, and we'll probably have to take an asset write down on our transmission infrastructure. But what will start to happen is the poles and wires in the street, hopefully they're below the ground, but they might be above the ground. Those poles and wires, and obviously with the help of a software like PowerLedger's software, can become an energy internet. So at the moment we have one directional flow. So, energy comes from a big power station to your house over a long distance, and it goes one way. But obviously in the future, we'll see those big generators dissipate, and we'll start to see houses all generating, all that roof space, for instance, with solar PV. And then we'll start to see bidirectional energy flows through that network. And that's what our software facilitates, this idea that we call the democratization of the electricity market. I've already referred to it as energy internet. We hear the term IoT a lot, which is Internet of Things. This is Internet of Energy. And really, a number of things have come together for that to occur. And in a decentralized market, so there's decentralization, the decentralization that's already occurring, the decreasing cost of battery storage, and the uptake and implementation at the household scale, in addition to a software layer that can settle transactions immediately, much different to our existing softwares that are used in the banking sector, for instance. Those things culminating together will lead to a more resilient and also decentralized network. And reason for that is if you take out one of the tiny generators, no problem. Energy is coming from everywhere. If your solar system breaks, it's fine. All your neighbors are exporting. Those are the types of things that drive resilience.
So I want to anchor this in what I feel like is a real thing, because I know there's people that talk about accelerationism and then there's decelerationism, and somewhere in the valley of the shadow of death between those two things is a tech positive serious concern about the existential risk posed to us by things such as the Yellowstone volcano eruption and like the potentiality of that eruption to create earthquakes that rupture a bunch of the nuclear reactors on the North American continent. Another one that I'm like, I guess, yeah. Well, in that case, actually, this was the subject of an unpleasant dinner conversation I was having with my aunt and my partner, trying to convince them to move to Australia, actually, because the jet stream should keep most of that radiation in the northern hemisphere. But at any rate, there's also, and I think kind of, globally, there's the issue of a massive solar flare and the fact that the electrical grids as they are now are, so tightly interwoven and so reliant on these transformers that do not themselves sort of possess sufficient grounding for this kind of a thing. That there were some, I forget the guy's name, but one guy in particular was going around in like 2008 and 2009 around the US and Europe trying to emphatically encouraging everyone to preparedly install massive surge protection in the transformers at every point. And I'm, it sounds to me like a system like the system you're describing would be much more capable of soaking up a system like that, like a tragedy like that, or hurricanes like that kind of. I'm just curious how you see this sort of disaster scenario stuff unfold.
Well, okay, the hurricane one's probably better, but just in terms of the solar flare, I mean, every male on the planet would be sterilized, so we might have bigger problems.
Okay.
And the energy market would probably be the least of my concerns. In terms of those arguments, look, it's all about risk, really. And Terence McKenna put forward a great thought experiment about this, where, for instance, say we meet our decarbonisation target. Global leaders sat down in Paris. We all agreed to not let global warming go above 1.5 degrees centigrade. But, say we do that, but then an asteroid strikes the planet and it's game over. Would we have been better placed to spend all that money and resources on an asteroid defense system? So I think one example is, really there's risks everywhere you look. And ultimately, you have resources and you have to put those resources somewhere and do something with them that you want to do. One of my friends, he's in the army and he goes to war zones, and I often asked him about, don't you get stressed out when you go to the war zone? For instance, if I put a foot wrong, it's not going to be my last step, but for you, that could be the case. And he pointed out to me that he goes, do you ever drive to work? And I said, actually, I don't. I catch public transport, but for the sake, let's say that I did drive. It's actually more dangerous to get in that car every day than it is to go. And the thing is we all get in the car every day, but none of us see that risk. Some people go to the beach and they won't get in the water for fear of a shark attack, but they'll drive to the beach and that's fine. And so where we put our resources, really, there's risk everywhere you look, and you just have to deal with the risk that's at hand. I mean, if a huge solar flare comes through and mass sterilization aside, would it damage the network? Absolutely. I mean, it will damage everything. It might even damage the electromagnetic field of the Earth. That we can't really control. So my view would be to assess the risk, look at what is most likely, and of the most likely, what aspects of that do we have control over, and then work across that. But I can't make any claim that decentralized network would be immune from a pulse from the sun. That I can't say.
Well, that's fair and to the point, I'd say. You mentioned in here this, like, the warrior mentality. And before the call, you mentioned that you'd just gotten back from some intense training. And I'm curious to hear you talk about that, if we can just pivot and take this into a different direction, but really into a kind of a continuation of the source of these questions about existential risk and the strategies that we have for managing them are, a source of understanding of ourselves and what it's like to be alive at this time. And I think that there's something about I have a friend in Europe who's very devoted to restoring like old Norse Viking wrestling as a sport at festivals and bringing back this culture of like safe and healthy masculinity. And that may seem like a weird pivot for listeners, but I know that we can weave it because you've already demonstrated the capacity to like see this in terms of successive waves and systems and such. So I'm curious where you take that.
Yeah. I mean, okay. So for me personally, I'm definitely more of a lover than a fighter. I think the way I see this, I, for instance, I'm outside of work. I know I'm very busy. So with work, obviously that's a huge commitment. I also write journal articles. I'm a researcher as well. But on top of that, I do a bit of physical training, and some of it, I guess, it's done with a functional perspective. And it's not CrossFit or anything like that, but the few places that offer that kind of services, they're generally geared at people that are training in the military, because the function there is not about mirror muscles. It's just about how fast can you run, how high can you climb, how far can you swim, how high can you jump, how much can you carry, that kind of stuff. And for me, I guess I'm a utilitarian in that perspective. So that's kind of what I've focused on. But what I've actually come to learn from doing that, and I do that every morning at 4:30 in the morning, and the training sessions go anywhere between 2 hours or 1 hour. Basically, the way I see it is it's not so much warrior mentality, it's more about mental resilience. And I'm a firm believer that if you want to increase your mental resilience, you do that through physical training. So, for instance, when you push yourself to the point that you want to stop, that's when it starts. And the way that you grow your resilience is by putting yourself in that uncomfortable situation. So from my perspective, I try and put myself in that situation every day. And for me, I find that it transfers well into my professional role. And I also find that as well into being disciplined and to punch out as many journal articles as I can. Because I think on some, if I just worked all the time, I probably wouldn't be as effective as I am through that development process. And for me, that's where it comes from. I do enjoy in the evenings boxing or jiu-jitsu, but once again, for me, that's just more of a, I guess you could say, a sport. There's not really something, I wouldn't necessarily encourage this kind of like tap out mentality where you go out and get someone to get in a fight or something. I mean, the way I see that kind of stuff, if you're really good at fighting and you go out and someone challenges you to a fight, I think you're an idiot to actually to reciprocate the offer. I think it's when a little kid might challenge you to a fight. I mean, and you're a fully grown adult. I mean, of course, you're not going to hit the little kid. And the other situation, also stands. I think if that happens in a bar situation and you're going to win, I mean, the best thing you can do is probably walk away anyway. And it's not the reason why you do it. I think it's just a great physical test, and there's nothing that forces you to train harder, which increases your mental resilience than that. And then to pick up where you started, I mean, yes, over the last 3 days, I attempted a 36-hour event called Cadre Camp. For those that are on Instagram, you can see it all on Instagram. It's at the Mill Gym. And basically, the purpose of this facility is, mental resilience. And the 36-hour cadre camp ostensibly is no sleep, no eating. It simulates special forces training. This particular course went for 36 hours. In Australia, the real deal goes for 21 days.
Holy shit!
I actually washed out before the end of the course, so I voluntarily withdrew. It starts at in the evening. It started in the evening on Friday. It went all the way through Friday night, all the way through Saturday, and they would have finished somewhere yesterday on Sunday. I got through to Saturday, and it was enough was enough. But basically, that point where you say you're running and you want to stop, well, that's the point they hold you at that entire time. And probably quite similar to what you guys have over in the States. I think you refer to it as BUDS, or like the Navy SEAL training, or Hell Week. But interestingly, it attracts all types of people. And I guess, you've got to work on all aspects of your life. I started this interview talking about how I meditate. That's one aspect. And I think, your physical body, is really all that you have. You might build up material wealth, and you might, in my case, get more publications and whatnot. And you may be very lucky enough to have a significant impact on the lives of others, a positive impact. But at the end of the day, you've also got to be healthy. There's no point maintaining that without maintaining a healthy lifestyle. And in order to get out of bed every morning and get on the rower for two kilometers, or lift something that you never thought you would lift, you need that discipline and you need that resilience. And so that's where all that comes from.
It's interesting. It's obvious, your consistency of character across disciplines, that there's an integration here, a drive towards resilience in all aspects of your life, if I may.
It's a good point. Yeah.
That's I think, in the way that, people bring character to work. The way that you could say, like, Steve Jobs had that thing with design that influenced everything he touched. And then actually I was connected to you through Robert Gordon in Perth also, who has this coaching practice, and I met him in Iceland at the seminar led by Sean Esbjorn Hargens, who, I don't know if you know Sean Hargens and the Meta Integral folks, but their whole thing, and like Sean's whole practice, I had him on the show to talk about how he structured his life to cultivate his head, his heart, and his hara, like his gut, to live simultaneously through, at the minimum, like all three nervous centers, to like live completely through a whole bodied approach, and to make sure that he was like constantly developing himself in all of these ways. And it seems in some sense that that Sean and you are both sort of animated by a similar holotropic drive. I don't know. What is it? I guess to put that in a question, what motivates you?
I guess motivation is an interesting thing. Actually, just bear with me, Mike. I'm just going to move.
Yeah.
So in terms of motivation, I guess you're on the planet for a finite period of time, and ultimately you want to do all you can. So in terms of my motivation, I actually don't know what drives me, to be honest. The why for me has generally always been to make a living and make a difference. And so I guess I've tried to stay true to that. And in order to achieve what I need to achieve, or what I seek to achieve, I guess it's about maintaining balance. And so through maintaining balance, that's how I achieve the goal, the mission. So that, I believe, is what drives me, to maintain that balance, to try those different things, to work on different areas, and to do that in parallel. You can just focus on one area, like you could just eat like bananas all the time, but then I think if you just ate bananas all the time, things would be really bad. So I think life's like that as well. And I mean, what you do for a living is important, but also that doesn't define you. There's many other things in your life that define you. So, it's about getting that balance right and striking that in an equitable manner. But I guess it's impossible to hold perfect balance. I think it's more like a spider web. And one thing kind of always starts to drift off, and you have to kind of focus more on that to pull it in, and then something else starts to drift off, and that's what that maintaining the balance is.
That reminds me of Buckminster Fuller talking about tensegrity, like the balance of forces in a geodesic dome. Everything sort of pulling and pushing against. You brought up a couple times. You brought up your research. You brought up publications. I guess what I'm asking is, how does this aesthetic, this organizing principle, express itself in the way that you conduct your science? I'd love to hear a little bit about what actually you've been researching lately, specifically, and what kind of work you've been publishing.
Yeah. Okay. So my research is actually right in the blockchain. So my background, I used to work in research and development for a number of years. And then I moved into government and ended up working for an Australian senator as an advisor in electricity space. I didn't start there as an advisor. I started there as an intern. From that, that's led to what I currently do. So I guess my roots are very firmly grounded in technology and technological innovation. Then a lot of the innovation that I was pushing for in my early days that we had proven to function was then inhibited by government policy. So that's what drove me into the government side of things. And then in the government side of things, it's actually very difficult to get change. There's a massive inertia to change to get progressive policy through. So that's what's led me back to where I am now. And now I kind of straddle halfway between government and obviously I'm very much in the private sector. But in terms of my research and how that all connects together is that's driven me to focus on very applied research. Now this isn't to say that if your research isn't applied, it's not valuable. Not all research needs to be applied. Doesn't need to be valuable in the sense that we would measure value, say, right now at this point in time. Boolean algebra is a great example of that. Boolean, when coming up with Boolean algebra, probably had the acclaim of 10 mathematicians around the world. That logic process underpins every digital device we now hold. At the time it was invented, there were no digital devices. So, sometimes time can be a factor in that. But in terms of how it's driven me, particularly in my research, is that I wanted to push the boundary, push the envelope in the decentralization of renewable generation and storage. And initially I was focused very much on decentralized renewable generation. My research project for my doctoral research is a housing development referred to as WGB, where we've built 110 dwellings over 4 apartment buildings. And what we've done is created an open source governance framework for any of those buildings in that site to put in a big central battery and solar system on the roof. Those findings, how we achieved that, the amendments to what you would refer to in the States as condominium law, we call it strata law, commercial modelling, system sizing, system architecture, all those frameworks that we had to overcome, all those barriers we overcame through those frameworks, we then have open source. So that means that any apartment building across Australia, so that's 30% of our housing stock, could now implement battery and solar at no cost for accessing the instructions on how to do it. And as I pointed out before, by the end of next year, it'll likely be cheaper to do that than by grid source electricity. So that was my case study for my research project. And in terms of how it influenced my approach, I mean, obviously we take very systematic, standard approaches to publishing information about that data. We certainly adhere to the peer review process. So, everything is falsifiable, repeatable, holding true to the philosophies of science. And ultimately what we do is produce articles whereby we're communicating what we've done in a way to incentivize other groups around the world to either take our research further. For instance, into other utility services, we've started plugging in electric vehicles into that site, but beyond. And so for me, I started in this research space solely focusing on the engineering and the renewable generators and how storage works. But ultimately what I've ended up working on and in is software, is protocols to facilitate the sharing or the peer-to-peer trading of electricity between those assets. And that's where things are at right now. So right now, obviously, part of Power Ledger and part of our solution came out of that research project. But success has many fathers and failure is an orphan. I'm sure there's a lot of stories out there. But yeah, ostensibly that's the story, that's the line, and that's where it's ended up. And for me, the mission has always been the same, to I guess, innovate with technology. And I've tried many ways to do that. But it seems that, working in a policy institute and in the private sector seems to be the way that gets the most change done at this point in time.
I'd be curious to hear you speak specifically to the kind of problems that you run into working at the municipal level with a project like this, and also working internationally and across a multitude of different regulatory environments. Because obviously one of the more interesting things about the blockchain revolution, or the decentralization of cryptographic technologies, however you choose to look at this stuff, the trend towards this stuff plants this kind of thing in a very exciting and important position, among these many, many exciting possible deployments. It's like, oh, it's transforming everything. But when it comes down to it, like basic access to electricity, to water, to stuff like that is obviously massive and historical shift. So what is that like on the boring paperwork front? What is that like on the having to convince people in the old guard that you're not a psychopath or a threat?
Yeah. No, so it's a good point. So I guess I'll premise this with, and not everyone in the world has access to electricity. So somewhere around 15% of the world's population have no access to a network. So roughly 1.2 billion people. So network access is actually it's a huge problem in a great deal of the globe still, and that's something that's slowly being eroded away. but that's still a very real reality for a lot of people on the planet still. So there are governments, big bodies looking at that in terms of connecting those people to electricity. So I'll just start by premising with that, not to forget, those people. But in terms of, where to from here in a regulatory space, look, I mean, innovation always outpaces regulation. Regulators don't sit there and think about a possible technology and write in a rule that may apply to it one day. I mean, it's not how regulation works, and it's not how we would expect it to work. But what it means is that innovation is actually driven on the other side. In my case, it's the technology side. I mean, other innovations occur in the social space, for instance, things like equal rights and whatnot. I mean, obviously technology companies have very little influence in that space. That's more of a government role, but generally in my particular space that I'm occupying now, which is electrical utilities, technology is king. And so, in terms of our platform and how it interfaces and interacts with different regulatory environments. So what we've done is each of us come from the electricity market. A few of us are blockchain as well. I mean, true to our name, Power Ledger. We're a mix of power people and ledger people. And so with that in mind, what we've done is created a product that not only is a finely tuned blockchain application that's robust, scalable, and efficient and fast, but we've also designed it in a way that it can interface with any electrical market around the globe. And the way we achieve that is that we see this as an evolution, not an extinction event. So the path we went down, and we've made, there's no secret about this, is, we are a software company, we're not an energy retailer. So for instance, the rules you talk about, for instance, apply to players in the energy market, by and large, in the energy regulation space. That would be fair. It'd be consumers and producers and all the intermediaries in between. So what we do is we've positioned ourselves similar to the Microsoft Excel. So we've provided the software that in different markets, different application hosts would have to host the software. So for instance, in America, one example would be behind the meter. So if you're inside of an apartment building, who looks after it then? So it would be the building manager. It wouldn't be the utility service. So if everyone lives in an apartment building and there's a solar system and battery, and like I say, if anyone wants to know how to overcome the legal barriers to do that, we have an open source governance framework to help you get through that. Then all you need to do is have the software, have the thing connected up, and then trading occurs through the Power Ledger trading engine. Now, trading over the regulated market, though, that's very different. So in order to trade to the building next door, although you might only be going through 5 meters of network infrastructure, there'll be a series of rules that determine who can trade energy over that network. Now, I don't know what particular state you're in, but depending on the state, let's just say it's a state where a retailer has the right to trade energy. Well, then, for instance, the retailer could use our software and offer you that trading service. Now, if it was a contestable market, so if in your state you have a choice of multiple retailers, so for instance, say you think your energy is too high, in some states you'll have the choice. You'll be able to say, I don't like this energy company anymore. I want to change companies. In that kind of space, in the contestable space, same rules apply. One of them would use our software, and then that would actually give them a point of difference in competition with the other company. And so what you'll find is that we're not actually changing the rules of physics. So you'll find that if you get your current clamps and your voltmeters, and you have a one apartment building or even just a regular house spilling energy into the grid, and even if they're getting paid for it or not, I know you guys have net metering. That energy is physically going to the closest point of consumption. Like Power Ledger platform, our software doesn't change those rules of physics. But what it does do is it can see that when this person's putting energy in and this person's next door and this person's pulling energy out, we can see that there was a transaction that occurred there, and we can reconcile that transaction immediately. We can settle it using our digital tokens. So person A or building A has a wallet, building B has a wallet, both wallets are digital. As units of electricity are going between the buildings, digital tokens or cryptographic tokens are going to the point of generation. And that's how it works. And so in that way, I won't sit here and list off every country and every different mode of application around the world. But basically what happens is our software can be in the market at some point. It just depends on who hosts it, and ultimately that's how it functions. So we designed the platform with that in mind, and that's why we've seen such wide international take-up.
So forgive me for not knowing this. I really, really, really meant to read the technical white paper before this call, and life has just been very full. But I'm curious, I know that the tokens are issued as ERC20 tokens on Ethereum blockchain, correct? Is all network activity in the electrical market on the Ethereum blockchain?
Yeah, so just to clarify, I won't go too much into this. We have a dual token system. Mm-hmm. So we have a power token, and some of your listeners may hold power. But we also have a spark. And so when people are trading electricity, they're trading the spark, which is the second token. So that token's not a cryptocurrency. It's actually just a digital index. The spark never changes in value. So in America, one spark is 1 cent. It'll always be 1 cent per spark. You might be selling energy, let's just say 20 cents per kilowatt hour. And that would mean that every kilowatt hour you consume of your neighbor's excess solar, 20 of your sparks are flying to his or her digital wallet. And that happens instantly. So that by on balance, that's how the platform works.
I just wanted to bring that up because I think that's an important distinction, in that when people worry about the tokenization of everything, it's not everything is actually going to be traded on an open market. And there are absolutely these things that you want to keep stable. So there's an ethical part of that.
Yeah, so not to get confused with cryptocurrency. So we do have a cryptocurrency that is the power token, but that actually performs a separate function. The realistic application in utility services at this point in time is a cryptographic token. And just to imagine like how that works already in society, it might be your nephew's birthday. You go to the toy store, you give them $50. They give you a bit of paper that says $50 on it. That bit of paper has no value. It's just worthless bit of paper with 5 and 0 written on it. But that then allows your nephew to return to the store and then redeem $50 of value to buy toys. So what we do is the same thing. Instead of a voucher or instead of a gift card or whatever, what we're doing is giving you cryptographic tokens for your fiat money, for the money that you receive from your employer or from your investments. And from that, then that converts into this digital token, which is then representing electricity. And so if you're exporting more energy than you're consuming, you'll be seeing your digital wallet fill up with sparks. All your neighbour's sparks will be flowing into your wallet. And then in that instance, if the energy retailer is the application host, you can return your sparks to the retailer and they would then redeem them for cash.
So what is the world like that you imagine this being fully deployed in? Like, I mean, obviously this is when we talk about speculative fictions, often the mistake is to look at one technology in isolation. And I know that someone like yourself must be seeing this from, tracking a dozen other technologies converging on, specific possible test points on the horizon. So, what is, if you could, as we're coming close to the end of an hour, I'd love to hear you describe the future that you're actively building, or like the future that you hope you're helping steer into, and what that looks like on a daily basis, how it works.
Great, and a great place to finish as well. So there's two arguments about this. Where is the energy network going? And so one argument is that we end up with what's referred to as the GEX, or the Global Energy Exchange. Some countries like China are very ambitious and are seeking to do that by building a large transmission infrastructure all the way down through Russia, through Europe and into Africa. And the way they foresee the future is one big global energy network. But the other competing viewpoint, and the one that I think is more realistic, is what's referred to the modular network. As cool as the Global Energy Exchange might sound, building a big network like that, it brings the same problems that we currently have. And the current problem we have is that we have long pieces of infrastructure that cost a lot of money. So by and large, the bulk of your energy bill is actually not the electricity you're using, it's actually the cost of the infrastructure to get it to your house.
Son of a bitch.
Yeah. So, and if you build a big global network, it's just going to still be super expensive. And what's going to happen is you'll build a huge transmission line out to an island where there's 30 houses, and those 30 houses will never repay the cost of that infrastructure. So that will then be shared by the whole network. I mean, as it should. You shouldn't penalise those people for being on the island. But the point is that old idea of having to build a big, long transmission infrastructure from a big centralised generator is over. So the way I personally see the future is decentralized, and that's what the trends currently already suggest. I see the future being modular. So, obviously in the States, you'll continue to interconnect over the state borders, and you may even interconnect into Canada and, into Mexico and South America. I mean, on one big landmass, it does make sense. But, for instance, Australia is a great test point, right, where we have a huge country. So the land area of the USA is pretty similar to the land area in Australia. But we only have a tiny fraction of your population. We have about 22 million people living here total. My city, 2 million, that's it. But what we do is we have a lot of land we have to stretch our network over. And so what we're starting to see is that you don't need to stretch a network over your entire state. Sometimes it's cheaper just to put a big battery and solar system or whatever renewable generator is applicable to that area in that town, in that city, because that's the cheaper way to do things. And so I personally feel that given the cost of infrastructure and the price of infrastructure and grid resiliency, we'll move to what's referred to as a modular network, where it's increased distributed generation, storage, innovative softwares like ours, but also further softwares that can encourage energy efficiency, turn down air conditioners or heaters when they're affecting the peak loads too much. Having a house and appliance that will actually interact with you, so beyond smart but intelligent. And those are the things I think the future network is, and I firmly believe that that's the way we're going.
So you brought it up. I did not bring it up, for the record. Okay, you brought up the intelligent house, the intelligent city. This idea. I just saw, I forget who it was. Somebody wrote a piece on smart cities for transhumanity.net, I think it was, and I've been getting their emails, and I've been thinking about this question because, Greg Bear and Greg Egan and all these amazing science fiction writers have been toying with this idea of, China Mieville, the sentient city, also Paulo Soleri, the arcology, this sort of city as organism. And so, I mean, do you feel like we are actually sort of creating a new form of life? Like, do you feel like Power Ledger is sort of in the process of facilitating a new, like, metropolitan super biology? I don't know.
Well, I think, like any biology, it takes multiple interacting forces, and we're just one of the many many organisms in there. But I guess it's more like a flock of birds flying. So there are many technologies in the smart city space, and we've been living in cities for thousands of years. Really, it's not a new concept, and always looking to innovate and make things better and more livable. I mean, for instance, in Australia, there's a big push from our federal government to. We have lots of people moving here, which is great. We really like immigration in Australia. I mean, we are all immigrants. We completely. We've all come here at some point. And we also have traditional landowners as well. And from our perspective, from our government's perspective, having people wanting to live where you live is a great problem to have. And so what we do is we focus on livability in our cities, and technology is the way to achieve that. So ultimately, the goal of smart cities is the same that the goal has always been for cities, human flourishing. But obviously now we're getting bigger and shinier toys to apply in that setting to make life easier. So, for instance, we play in the electricity space, and we can automate transactions on the energy market. But, obviously that's one utility service amongst many within a metropolitan setting. So, we are certainly part of that. We're not the main driver. But, we will start to see cities go from beyond smart to intelligent. And I mean, really, technology is just the extension of us. We're really just inside of a larger being, a larger organism. And, ultimately that would be the Earth, and you could probably scale that out over the galaxy. It's all about the scale at which you're relative to. But bringing it back down, we certainly see what we're offering is a great leap forward today. But obviously in 20 or 30 years' time, with quantum computing and whatnot, things will also be very different. So I think it's an exciting space to be in, and I guess watch this space.
I like ending the calls in a place of heart, because I feel like it, if this show is as I pretend it is, a message to people that will dig it up one day, trying to understand what it was like to be us, going through all this craziness. Then you brought it up earlier in the call that 15% of the people still lack network access to the electrical grid, and that's a theme you hear lots of variations of in the blockchain space. The 2 billion unbanked people. The way that we're trying to cross the gap of that last kilometer of missing infrastructure and provide services and provide opportunities for wealth generation to the world's poor. And I'd like to hear you speak to that. Maybe that's the way that we can sign this off, is that there's something about the meek inheriting the earth here, if I can get a little heavy-handed with it, that just as mobile payments shows up first in Africa because they don't have the banking infrastructure, that there's a sense in which the city is both helping us with this innovation, and also maybe it will find its natural footing first in these places where there's less legacy infrastructure in place. I'd love to hear you speak to that.
Yeah, great point. And that's exactly what we're finding. So obviously I've spoken quite extensively about cities. I did mention that a large portion of the global population don't have access to electricity. You're absolutely right. A lot of our projects are actually in those areas. So basically, with the Power Ledger platform, for instance, if you have a village and they can get a solar panel and maybe multiple people want to use energy from that panel to charge their phones, which is super common, then, it would be, sometimes you can just time how long the person spends charging their phone but basically the cost of our software is so low, it's almost non-existent, particularly in that application, that what would happen is that solar panel would generate revenue. So if they didn't use the solar panel, it would either be that fuel would be entering the town in the form of diesel, and then the money would be leaving, it'd be going to where the diesel came from. So once you can stop that cycle, you can have renewable generation on site. That actually traps the value in that village or community. And so if you're providing a service where there's just one panel, that can then pay for another panel and another panel and another panel. And soon the village will probably want a battery so they can keep energy going all night. But then what will happen is that phenomena will be taking place in the village next door as well. And so by capturing that value in the town, that can actually empower those individuals to own their own network. And what the town's going to do is finance a line between the two to trade between towns en masse. And so those are the types of projects we're starting to see unfold. My research is heavily involved in smart cities, so I do kind of tend towards that in my discussions. But yeah, the tabula rasa of a greenfield, city that needs an energy network means they can get the futuristic energy network that you would build today. Whereas over here, in the developed world, we inherit our networks from previous design methodologies. So in terms of blockchain and its liberation and emancipation of individuals that are currently marginalized and delegitimized and are in emerging economies, this is certainly a crucial tool for cutting the middle person out and letting the profit and value stay in the villages, in the hands of the people that need the services most. And so from our perspective, and look, with my policy writing hat on, you can have electricity without an economy, but you can't have economy without electricity. And so we see this as a cornerstone for really making the world a much more equal and fair and just place.
Right on. James Eggleston, thank you for being on the show, dude. It's been a pleasure.
Thanks for having me, Michael.
Where can people learn more?
Great. So you can come to our website, which is powerledger.io. You can follow me on Twitter at James by Chance. And I look forward to hearing any questions if anyone would like to send me something over Twitter.
You have it, folks. Thanks a lot.
Thank you, Michael.
Thanks again for listening. I hope you enjoyed that episode as much as I did. Future Fossils is part of the MindPod network, along with Third Eye Drops, the Astral Hustle, Synchronicity Podcast, and an oodle of other fascinating programs. I encourage you to go to mindpodnetwork.com and subscribe to them all. And stay tuned, because we have some awesome episodes coming up on Future Fossils. But for now, may your now be exquisite, long, and wonderful.
Understanding that we've got a lot more to learn. The work is not done here.